Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to Learning by Solving Problems, Session 6 on NMR, Structure Elucidation of Organic Molecules. Deduce the structure of C8H8O3 and assign all proton and carbon-13 NMR signals. From the molecular formula, we can calculate the unsaturation number. U is equal to C plus 1 minus half X minus N. We have tetravalent element C8 plus 1 half monovalent element hydrogen 8. That makes unsaturation of 5. From 1D NMR signal recorded at 500 MHz in chloroform, we have 5 signals, 1, 2, 3, 4, 5, and we can summarize the data as usual: chemical shift, multiplicity, J constant, integration, and assignment. The peak at 3.83 singlet, it's 4 proton, and more likely to be CH3 group and OH. At 6.81 we have doublet, 8.25 coupling constant, 1H, 7.30 doublet, J value of 1.67 1H, 7.43 doublet of doublet, 8.25 and 1.67 coupling constants, and integration of 1 proton. These peaks are in the aromatic region, so most likely that we have tri-substituted benzene ring. And this hydrogen will be doublet with J3. This hydrogen will be doublet but J4. And this hydrogen will be doublet of doublet. Signal at 9.47 characteristic for aldehydic hydrogen, singlet, it's 1H, CHO. For the integration, it's the first peak around 4 hydrogens. We did sum the integration under the peak, total of 8 to 8.7, and the integration for the first peak is 4.07.9 divided by 8.2, 8.7 times 8 proton in our structure C8H8O3, so we have 8 hydrogen. That makes this peak of around 4 hydrogens, and each one of the rest is 1H. As you can see, peak 2, J value 8.25 in hertz, that's J3. Here is 1.67, that's J4 for aromatic, and that is for doublet of doublet. So we can say that we have this fragment, pretty easy. This is doublet with J value 1.67, J4. This is doublet with J3, 8.25, and this one H4, doublet of doublet. From the carbon-13 normal mode give us 8 signals, which means that there is no symmetry in this molecule. We have C8 and we have 8 signals for carbon decoupled. So that's what we have here. We got the depth 90 degree. In depth 90 degree, only the positive will be CH and the rest of the peak will disappear almost. So we have C2, C3, C5 has H, that's CH, and C1, C4, C6, C7 disappeared, and the peak at 196.36, that is the aldehydic carbon. Of course, it has one H. To distinguish between the quaternary and CH3, we got depth 135, so the CH will be positive and CH3 will be positive and CH2 will be negative. We don't have any negative peak, but we got here CH3 at 1 positive. So now we are sure that the first signal contains CH3, so it's CH3 plus 1 H. We will get to that when we get the HSQC. From the data we get so far, we have C8H8O3. We have the fragment C6H3, this one. We have aldehyde functionality. We have methoxy from the integration as well as chemical shift proton and carbon 13. And we have the remainder of OH. So how many fragments we have? 1, 2, 3, and 4. How we can connect these together? There is a lot of possibilities that we can draw for the structure. But which one is correct for our compound? How we can assign the correct one? From HSQC, we can get the relation between the proton and carbon. Link together carbon and hydrogen with J1. So we can clearly see that C1 is connected to H1, right? C2 is connected to H3, right? C3 is connected to H2, okay? C4 is quaternary. C5 is connected to H4, right? C6 and 7 quaternary carbons. And C8 is connected to H5. So, this is 8 and 5. Here is 3, and so this should be 2. This is 4, so this is 5. This is 2, so this is 3. And we have an OH and one C1 and H1. That's CH3O. So we just ensured that we have the same fragment, that's right, and we get the connection between carbon and hydrogen from HSQC. That's what we have from HSQC. What about HMBC? That's long range coupling. So that's J3 and J2. H1 is connected to C6. That's H1 connected via J3. That's 1, 2, 3, to H6. Okay. Hydrogen 2 is connected to 4 and to 6. H2 is connected to 4, again J3, and J3 again to 6, right? H3 is connected to 5, 7, and 8. H3 is connected to 5, J3, 7, 1, 2, 3, J3 again, and 8, 1, 2, 3. Okay, and then H5 is connected to 2, 4, 5, and 6. From this data, we can assign that this is 4 quaternary, this is 6, and this is 7. From NOESY, now we know that the aldehyde 5, H is connected to 2 and 5 and 4, so this must be 4. So the aldehyde is on carbon 4. What about the OCH3 and the OH? If we have this structure CH3, this hydrogen will be in space close to H3. So we have correlation between 1 and 3. That is correct. We have connection between H3 and H3 to H5. So H3 with H5. Also CH4 to H5. CH4 and 4 and 5 connection. So we now know that this part is correct, and the upper one now is correct because there is a correlation between CH3 protons and H3 in space. So this is the structure. To have the final check up, the calculated and the observed. This is observed for proton, matching well. And the carbon 8 carbon are matching well. To add one more, you can check the literature, that is vanillin, and already the spectra for the vanillin was reported in 2009 in Journal Physics Conference Series, and the data obtained matching well with our unknown C8H8O3. This is the protocol of solving unknown structure. Enjoy it. See you next session.